Okay, welcome to Chapter 6. We're about to finish up Chapter 6, and we're going to deal with rational expressions and equations still. We're going to talk about them in applied problems. These are your favorites. These are your word problems. But one of the formulas that we're going to be using is really doing with proportions. And y'all are pretty good at those. They're motion formulas. So distance equals rate times time, or rate equals distance divided by time, or time equals distance divided by rate. So, for example, Rayanne drives 20 miles faster than her mother, Catherine. In the same time that Rayanne travels 360 miles, her mother travels 240 miles. Find their speeds. So you can make a drawing and we can look at a couple of different things. Basically, all I'm going to do is I'm going to select R plus 20 equal the speed of Rayanne. So Rayanne equals R plus 20, and her mother equals R, because we're trying to find the speed of Catherine. Okay. Now, how many miles did it say that they travel? Okay. Catherine travels 240 miles, and Rayanne travels 360 miles. So we're going to try to find their speeds. So basically, Catherine, the mother, travels 240 miles, and Rayanne travels 360 miles. Again, we're still talking about distance equals rate times time. So distance equals rate times time. So if we put it in a grid, so it looks something like this. We can say Rayanne drives 360 miles, and that is the rate plus 20. Okay, and her mother drives 240 miles with just the regular rate. Or that's how we put it in a grid. And so then we're going to move on. And then so let's do some translations. If we think about it, 360 equaled the rate plus 20 times t for Rayanne, and for her mother, 240 equaled the rate times time. Okay, good so far? So that's our formulas that we have so far. Now, if we set them up to where we're trying to find t, because we need to know what the time is. So if we try to find up, and since t is in both of them, we can change this around to t equals, based on what we were given earlier, the distance divided by the rate for Rayanne, and for Catherine, we're going to have t equals 240 divided by the rate. So we can say 360 over r plus 20 equals 240 over r. Does that look familiar? Now you've done that before. So basically, if we set them equal to each other, you can do what's considered a proportion and go straight across. Remember, I call it doing the butterfly. So we're going to multiply this way. So now we have 360r equals 240r plus 4,800. Okay, so 240 times 20 is 4,800. So we're trying to find rate. So if we subtract 240r from both sides, what do we get? 120, very good. 120r equals 4,800. Divide by 120 on both sides. So r equals, what do you think r is going to equal? Very good. R equals 40. So we found the rate of Catherine. So Catherine, her mother, drives 40 miles per hour, so Catherine equals 40 miles per hour. And Rayanne, remember, was 20 miles more than that. So 40 plus 20 equals 60 miles per hour. Another word problem we have is Juan and Rebecca work during the summer painting houses. Juan can paint an average size house in 12 days, while Rebecca can paint or requires 8 days to do the same job. How long would it take them working together to paint the average size house? Now you have to think about some things. You can't just say 12 plus 8 equals 20 because that's not going to work if you add the two times together. Now you can also try to assume that each are painting half of the house. That's not going to work either, because if one does half of it in 12 days, that's going to be 6 days. And if Rebecca does half of it in 8 days, half of 8 days, that's 4 days. You add those together, that's 10 days. That doesn't make sense either. So let's think about how much they would finish. So if it takes Juan 12 days to finish painting a house, his rate is 1/12 of the job per day. Think about it. 1 day out of 12. So we're going to say Juan is 1/12. Let me get my pen to work. So we have 1/12 for Juan. Now let's go back and look at Rebecca's. What would hers be? Very good. 1 out of 8 days. So we're going to say 1 out of 8 days would complete it in 1 day. Now remember, we're going to add these together because we want them to tag team the house. So we need a common denominator, so it's going to be 24. So 12 times 2 gives us 24. So 2 times 1 is 2. And then, so this winds up 2 plus 3. I'm already trying to give you the answer there. Plus 3. So we get 5 days out of 24 it would take them to complete the job. Okay, 5 of 24 of the job in 1 day. Now, or 5/24 of the job in 1 day. Now, we need to create a table to kind of make this work a little bit better, because remember, looking at the rate of time, so we have 1/12 times, or for 1, and we need to know what the time is, the amount completed. So let's think about how we would work that. If we let T be our time, so if we multiply both of them by T, if I can get this right here, both of them by T, plus Rebecca's time, that should equal 1 whole day, okay? The portion of work done by Rebecca in time. So let's see if we can remember, we came up with a common denominator. So we had 5/24 times T equals 1. That's 1 complete day. Now, we need to know how many times it takes them to, or what the time it is, how many days it's going to take them to complete it. So how do you get that T by itself? You multiply both sides by the reciprocal. So when you do, you get 5/24. So, I'm sorry, 24/5. Let's write that correctly. I said reciprocal, but I didn't flip it, did I? So we're going to say 24/5 and 24/5. So this is going to cancel here. So we wind up with T equals 24/5. So 5 goes into 24 4 times with a remainder of 4. So it's going to take them 4 days and almost all of another day. That makes sense. So we are done. Okay, so it takes 4 4/5 days to paint the house together. Extra slide we don't need. Alright, the work principle. This is where we're doing work, and it's how much it takes to do a job. That's basically what we did. If we put T over the amount plus T over the other amount of the other person, that equals one whole. Okay? Equals one whole. So if we work on that, we can come up with how much it takes to do a job together. Now, problems involving proportions. These are ratios, and these are things that we have done before. So this will not be a surprise. Okay, a sample of 186 hard drives contain 4 defective drives. How many defective drives would you expect in a sample of 1,302? So 4 out of 186 equals 13 over 2, and we're looking for how many of those would be defective. So again, we're going to do the butterfly, so we get 186x. Now 4 times 1,302 is going to equal 5,208. We're going to divide both sides by 186. Okay, so x is going to equal 28. So we could expect 28 drives, hard drives, to be defective out of 1,302. Okay, so we're going to determine, it's wanting us to determine the number of humpback whales in a pod. Okay, so we're going to estimate the number of whales in the pod. That's what we're looking for. How many are in a pod? A marine biologist using tail markings identifies 35 members of the pod. Several weeks later, 50 whales from the pod are randomly sighted. Of the 50 sighted, 18 are from the 35 originally identified. So what is the estimate of the number of whales in the pod? So since 18 of the 35 whales that were sighted, that were later sighted, were among those originally identified, the ratio of 18 out of 35 estimates the percentage of the pod originally identified. We can then translate this to a proportion. So when we translate this to a proportion, we're going to kind of look at it a different way. You can do it a couple of different ways. I'm going to say 18 out of 35 was the original, equals, we came up with 50. So we're trying to see how many are in an entire pod. So I'm going to say W. Okay. So we're going to do 18W equals 35 times 50. So let's see, 35 times 5 gives me 25, 15, 16, 17. So equals, and that was really times 50, so we've got to add a 0. Equals 1750. We're going to divide by 18. So W equals around 97. So if we use our calculator, actually, I forget, you can use your calculator. So 1750 divided by 18 is going to give us 97. 97.22 of our whales. Okay, so approximately 97 whales are in a pod. I would actually probably round that to 98, just because you can't have part of a whale. But realistically, 97 would have been the correct answer because that's rounding, so that would have been fine too. Okay, let's look at this. Let's draw triangles first to make sure that we understand the problem. So I'm going to draw a triangle ABC. So here's A, here's B, here's C. And it said that side A, that's this one here, is 7. Then we're going to draw a triangle X, Y, Z. Said that side X is 8 and side Y is 12. So if you line things up based on where their sides are, this is lowercase b. So lowercase b, because that's what we're looking for, is our side b. So b over 12 equals 7 over 8. So I get 8b equals 7 times 12. What? 84? Divide by 8. So b is approximately going to equal 10 and a half. Okay? So that's your final answer. The approximate length of side B is 10.5 or 10 and 1/2, whatever the measurements are. Okay guys, that's the end of the chapter. That is the end of Math 098. So you are good to go. Work on your study guide, work on your homework problems, and good luck on the semester exam.